Yeah, and one more thing about those mechanoreceptors, those are human trained. They're trained by the body.
Yes.
It's not something that we just grow into. It's not something that everything has. Humans have developed them. That's what wakes you up in the middle of the night, these mechanoreceptors. When you wake up in the middle of the night like me and you have to use the restroom because you drink too much water, that's what's waking you up, these mechanoreceptors. And my 2-year-old daughter doesn't have any yet because we're teaching her, we're potty training her. So right now there's nothing that kicks off in her body that says, I got to wake up because my bladder's filling up. They just release it. Same thing with dogs. Dogs will just release it, and you teach them their body to adapt with these mechanoreceptors or to start to engage with them once you potty train them. And once you say, hey, don't do that in the house, the dog will hold his bladder until it's time to go out, and he'll start scratching when it's time to go out because we have now reinforced this mechanoreceptor in the body.
Yep. And like I said, if you drink it too fast, you're more likely to secrete it just as rapidly or more rapidly than if you were to just sip it.
Yeah. Yeah, they say with the first 10 hours that you're awake, you drink 8 ounces an hour. So you need to drink 80 ounces when you're a person at rest. And that's just what your body needs. Like we talked about, the water doesn't sit in your body. It's not like some of these other materials in the body that'll just sit and then you can burn it when you need it. Nope, water is constantly moving. It needs to constantly be flowing. So when you wake up, your body's ready to start purging. Your body's ready to start refreshing the water in your cells, in your different systems. So the kidneys so the body's saying, hey, give me water, and the kidneys will start working, and it'll start pulling the water out of your body for new water. So they say about 8 ounces an hour for the first 10 hours. So you should be drinking 80 ounces. That's an easy thing to remember. You know, if you got a 16-ounce water bottle, or mine's 24, I know I have to drink that every 3 hours. That's kind of how I do it. So I'm drinking a multiple a day. And then if you're working out, you should double or triple that depending on if it's hot outside. So for that hour, you should drink 24 ounces instead of 8. So that's kind of something to go by. And then that's because it's part of your circadian rhythm. After those 10 hours, the body's like, okay, I purged the water that I needed to. I've replaced the water that I've needed to. My body's going to stop. My kidneys are going to slow down in processing water. And then a few hours later, I'm going to go to sleep. So.
Yep, exactly.
That's the process for the body. And like Jordan, you talked about the two types. You want to talk about that a little bit more, the aquaporin and the diffusion?
Yeah, well, the diffusion is where it goes from the water goes from highest concentration to lowest concentration. So if it's concentrated in a specific area and there's lower concentrations, it will move towards those areas, and they call that diffusion.
Yep.
And then if it's the aquaporin channels, well, these channels are hydrophobic, but they'll accelerate the water through them. And it does so, I think it's like 1 million water molecules per second. That's how fast these channels are. Like, that's how fast the water gets processed through these channels. And these channels are mostly throughout the body, but not everywhere. So, equal in nature, different in degree. Your body needs water everywhere, but not everywhere will you find these aquaporin channels.
Right, because it doesn't need them fast.
It doesn't need the water as fast in those specific regions.
Yeah, and when Jordan is talking about 1 million, it's 1 million molecules per second. It's 1 million water molecules per second that move through these aquaporin channels. And that's why I stressed early in the episode why water being polar is so important for the body. Because it's polar, it's like a magnet. So when it's around hydrophobic materials, and in the body, that's like lipids or fat. When you pour oil inside of water and the oil kind of looks like amoebas or like little circles, and it doesn't mix, that's hydrophobic. It doesn't like water, doesn't want to be around it. So imagine that most of your cell membranes, they're lipids. It's a dual membrane, and it's a fat. And so you have these channels through the cells, and that's these aquaporin channels. So when the water molecule gets close to it, it's like a magnet being shot through. It's like if you take a magnet and you orient it a certain way with the negative side down, and then then you have a negative round magnet, and you were to drop it in it, it's going to push it through it because no part of that magnet, the big magnet, the round magnet, wants to be near the little magnet. So it'll shoot it, right? With the tremendous force. And that's kind of what the body's intelligence is taking advantage of here, is that
Yes.
hydrophobic nature, that polar nature of the water molecules.
Mhm.